Hello, ladies and gentlemen, this is Miss Stratton. So, today we're going to be talking about states of matter, and the very first thing we're going to do for this note taker is we're going to write down our LEQ. So, our less than essential question today says, how does matter change from a solid to a liquid to a gas? So, go ahead and record that, and then you can go ahead and move on. Alright, so ladies and gentlemen, before we move on, we're going to talk about what a state of matter is. First things first, a state of matter is a physical property. And a physical property, with that we see the properties of the matter itself. Things don't have to be changed in order to observe a physical property. So with states of matter, that's different phases in which any state of matter any type of matter can exist. So lead, for example, can exist as a solid, a liquid, and a gas. Lead is a lot more likely to exist as a solid because it has to be heated to such extreme temperatures to melt or even more to boil and evaporate. So lead can be a solid, liquid, and a gas, but it's just much more difficult. Water, however, naturally exists in all three states. So now what we're going to look at is the first state we're going to look at is a solid. Now a solid has an ordered arrangement, and it has a fixed volume and a fixed shape to help so that it keeps its shape. The particles in a solid are packed really closely together, much more closer than our other three states we're going to be looking at. There are two types of solids we're going to be observing: a crystalline solid and an amorphous solid. A crystalline solid, the particles are arranged in a regular repeating pattern. A good example of this would be the rock candy that we made in the lab. So if you look closely at that, you could see that there was a definite shape that those crystals took because they have that regular repeating molecular structure. However, amorphous solids do not have a regular repeating pattern. The particles are arranged randomly. A good example of that is glass. When you take a liquid glass, you pour it out, you can shape it into pretty much any shape because the particles are arranged at random. Alright, so the next state we're looking at is a liquid. In order to move from a solid to a liquid, we have to increase the energy or increase the heat. So a liquid has a fixed volume but does not have a fixed shape. The particles slide or flow around each other, and it takes the shape of its container. That property of liquid, that taking the shape of its container, is what allows us to measure it in a graduated cylinder or beakers or things like that. We can't measure the volume of a solid in a beaker because it doesn't take the shape of its container. So a liquid has an energy level between that of a solid and a gas. Alright, so our next state we're looking at is a gas. Now a gas has neither a fixed volume nor a fixed shape, which is why gases work well in balloons and why we can make balloons in really any shape we want to. I think at some point we've all tried to fill up a balloon, and then we've taken our hands and tried to squeeze it. So because it doesn't have a fixed volume, that's what allows us to squeeze it. It doesn't have a fixed shape because that again enables us to squeeze it. So the particles in a gas are spread out and they move freely around each other. Particles move in all directions at great speeds, and the particles in a gas spread out and fill its container. We have all experienced this. There has been many times where someone sprays Axe or something else very strong smelling on one end of the 7th grade hallway, and pretty soon you can smell it all the way at the stairwell. That is because gases fill their container, and there is no organization to how gases are arranged. They're in total disorder, and they're at a very low density. Now, plasma is the fourth state of matter that you probably are not as familiar with, and that's because it's a lot harder to observe in our world. Plasma, like gas, does not have a fixed volume or a fixed shape. Plasma is made of ions, which you should remember are charged particles. They can be either positively or negatively charged. And plasma conducts electricity and is magnetic. So you're going to see plasma in things like lightning and the sun and things like that. Things that are at extremely, extremely high temperatures, extremely, extremely high energy levels. All right, the next thing we're going to look at is how we change from one state of matter to the next. The state of matter changes as more energy is added. This can also be said that the state of matter changes as more energy is taken away. So in order to move from a solid to a liquid, we have to add energy. In order to move from a liquid to a gas, we have to add energy. In order to move from a gas to a plasma, we have to add lots of energy. And also I want you to write down that phases change as temperature changes. So in order for a phase to change, there has to be a change in temperature. All right, so next we're going to look at this guy. So this triangle you see here is just showing you what we call it as we move from one state of matter to the next. So we move from a liquid to a gas. We call that vaporization because our liquid is turning into a vapor. I'm sure you've heard the term water vapor before, and that's just what we're talking about here. When we move from a gas to a liquid, that's called condensation. Condensation, you've probably experienced that if you put out a cold glass of water on a table. You come back to it later and your glass is covered in water. It's not because there's water seeping out of your glass. It's because there is water vapor in the air, and that water vapor in the air is condensing when it comes into contact with your cold glass. So vaporization is going from a liquid to a gas. Condensation is going from a gas to a liquid. Now, when you move from a liquid to a solid, so when we go from a liquid to a solid, that can be called, that's freezing. So a liquid to a solid is freezing. That's if you put water in the freezer, it becomes an ice cube. That is freezing. When we go from a solid to a liquid, that is called melting. Now, these are two terms you're probably not as familiar with. When we go straight from a solid to a gas, that's a process called sublimation, and this is something that if you've ever seen dry ice or anything like that, that's what dry ice does. Dry ice doesn't turn into a liquid; it goes straight from a solid to a gas. That's also can actually be seen with snow. You may notice sometimes that when snow goes away, it doesn't always all turn to a liquid first. It seems to just disappear. And that's because we're seeing this process of sublimation. And the last thing we're going to look at here is something called deposition. And it is much less common. It's when we go straight from a gas to a solid. And I'll actually link a video after this showing you an example of that with an iodine gas that turns straight into a solid. But that's what that's called. All right, last but not least, we are going to look here, and it's just showing you how we move from one state to the next. So this is states of matter with water at different temperatures. We go from an ice at below 32 degrees to liquid water from 32 degrees to 212 degrees, and finally above 212 degrees, we boil. All right, ladies and gentlemen, that's going to wrap up this set of notes. So as always, whenever we do notes, you need to do a summary when you're finished. You can either do that at the bottom of the page or on the back. I would like your summary to be a minimum of 4 sentences talking about how does matter change from a solid to a liquid to a gas. All right, thank you guys. Have a good one. Bye-bye.